my fellow classmates and to our lecturer, Mr. Herman. Today, our group would like to present about the three-phase system that are used nowadays. Most of the electrical power generated in the world today is a three-phase electricity. I mean that it is used in houses, buildings, and industrial buildings. Generation, transmission, and heavy power utilization of AC electric energy almost invariably involve a type of system or circuit called a polyphase system or polyphase circuit. I'm Haris will talk about the basic principle of the three-phase system. The principle of a three-phase generator are basically the same as that of single-phase generator, except that there are three equally spaced winding and three output voltage that are all 120 degrees out of phase with one another. The individual coils of each winding are combined and represented as a single coil. The significance of figure 4.1.1.1 is that it shows that the three-phase generator has three separate armature windings that are 120 electrical degrees out of phase. You see that the first one there shows the first phase, the second one shows the second phase, and the third one shows the third phase. And that's the 120 electrically degrees.
Okay. Excuse me. Excuse me.
Asik kau selip.
Apa gaji? Gaji. Iya.
Jangan main-main. Dah tu.
Orang muda.
I will talk about three-phase system configuration. Advantage three-phase system: the house power rating of three-phase motor and kilovolt time rating of three-phase. Transformer is about 150% greater than for single-phase motor or transformer with a similar frame size. The power delivered by a single-phase system will set. In a balanced three-phase system, the conductor need to be about 75% the size conductor for a single-phase two-wire system or the same kVA rating. The efficiency and power factor of three-phase motor much better than single-phase motor for the same power transfer. Three-phase motor have the ability to self-start, caused by the fast difference between three-phase coil, but not in single-phase motor. Three-phase transformer for the same size. When connected in parallel, single-phase generator present difficulties which do not assure with the phase generator. This is the magnetic field moving, coil is static. Coil is moving, magnetic field is static, but there was the same magnetic coil rotation 120 degrees. 3 EMF generation. Just as we saw how single phase AC is generated by rotating a coil through magnetic field. If they similar loop fixed to each other at 120 degrees on a common spindle and rotate connected to slip ring on the shaft. R, Y, B on 3 coil turned finish and R1, Y1, B1 are turned start when rotated anti-clockwise at uniform speed in magnetic field due to NS. When moved by 19 degrees, EMF is RP. Same max generated EMF in YY1 and BB1 have same amplitude as in RR1, but lag by 120 degrees and 240 volt respectively. Interconnection of three-phase. If the three armature coil of the three-phase alternator are not interconnected but are kept separate as shown in figure 4.2.3.1, the each phase or circuit will need two conductor. The total number of conductor in that case being 6. It means that each transmission cable will contain 6 conductors, which will make the whole system complicated and expensive. This example for the wave. The three-phase rotation is 120 degrees. V1 is 120 degrees and V2 120 degrees, V3 120 degrees. Pause.
One.
Okay.
Connection and vector phase diagram. Star or wire connection. In this method of interconnection, the similar end says start end of three coil is called V finishing and also are joined together at point and as shown in figure 4.2, 4.1. The point or natural point. This is star circuit, but then delta. This is
Okay, that's all.
what's that?
Delta or mesh connection. In this method of interconnection, the dissimilar end of three-phase winding are joined together. The starting end of one phase is joined to the finishing end of the other phase, and so on, as shown in figure. In other words, the three windings are joined in series to form a closed mesh, as shown in figure. Phase and line element in three-phase system. The three conductors leading away from the voltage source winding toward a load are typically called line, while the windings themselves are typically called phase. When we measure voltage and current in three-phase system, we need to be specific as to where we are measuring. Line voltage refer to the amount of voltage measured between any two lines. Conductor phase voltage refer to voltage measured across any component. Line current refer to the amount of current measured through any one line conductor. Phase current refer to the amount of current measured through any one component. Voltage and current in star or wire connection. Voltage figure 4311 show the three-phase 4-wire star connection. In this connection, there are two phase winding connected across each pair of terminals. Therefore, the line voltage between two line conductors is the sum of two phase vectors. For instance, if we the terminal R and Y. Mutual current. In the sum of the three current I, E, IR, IY and IB having same magnitude but 1 to 0 different in phase. Therefore, mathematically, then sum of this vector will make natural current IN equal 0.
Voltage and current in delta or mesh connection. In delta connection, they will connect in closed mesh, while each pair of line conductor is connected directly across a single non-neutral wire. In this connection, namely 3 paths and 3 wires. This is line voltage and current for three-phase and 4-wire star connection. Voltage and current in delta of mesh connection. In delta connection, there are 12 connected in closed mesh, while each pair of line conductor is connected directly across a single non-neutral wire in this connection, namely the test negative wire.
Three. This is example of voltage phasor diagram for star connection. Delta and star quantities. The output voltage or current level of three-phase generator depends on which connection of the three armature coils is made, Y connection or delta connection. The two connection diagram of three-phase source together with the corresponding voltage or current. The Y-connected three-phase source has common terminal of the three coils labeled N, which is called a neutral, not a terminal of the source. Figure 4.2.3.1b shows the voltage phasor diagram of a Y-connected balanced three-phase source where the phase voltage VA is regarded as the reference with the phase angle of O degree. The relationship between the phase or line neutral voltage and the line or line to line voltage can be written as follows. VAB equal to VA minus VB.
Tiga.
Note that for a Y-connected three-phase source, the amplitudes of line voltage are 3 times that of phase voltage, and the line current is the times as the phase current. VI equal to 3 VY and I equal to IY. The current phasor diagram of a connected balanced three-phase source where the phase current length is regarded as the reference with the phase angle of 0 degree.
The relationship between the phase current and the line current can be written as follows. For a connected three-phase source, the amplitude of the line current are 3 times that of phase current, and the line voltage is the same as the phase voltage. Balance load in a three-phase system. Balance load in a three system have identical impedance in each secondary winding. The impedance of each winding in the delta load is shown as ZD, and the impedance in odd load is shown as ZY. For either the delta or Y connection, the line A basically supply a three system of voltage.
Tiga.
Okay, this is the example of hospital. Okay, this is the example of balanced three-phase system. As you can see, there's something like that. Okay, power of three-phase system. Total power is equal of 3 times the single phase power, and the question below here is the mathematical represent for the total power in balance delta or Y load. So total power equal to 3V I cos theta. Okay. In a delta connected to load, PL equal to V and I equal to square root 3 IL over 3. So total power equal to square root 3 VL IL cos theta.
In a Y connected load, IL equal I and V equal to square root 3 VL, so 3 A over 3. So PR equals square root 3 VL IL cos theta. The efficiency is equal to power up per power in and times to 100%.
Voltage and current in delta voltage connection. First, in delta connection, three coils connect in closed mesh, while each pair of line conductors is connected directly across a signal. Second, there is no natural wire in this connection, namely three pairs of three wires. Phasor diagram. Voltage phasor diagram for star connection. The process to draw voltage phasor diagram based on basic phasor diagram of three-phase system. Phasor diagram. Voltage phasor diagram of star connection. First, the process to draw voltage phasor diagram based on basic phasor diagram of three-phase system. Thank you.